Hi, friends. Um, whoa, my microphone probably sounds horrible right now. Give me one sec, bro. Whoa. Okay, that should sound better. Hi, guys. Trey here. And today I did day 13 of the Advent of Code, and no, I did day 14. And let's just say I locked in, like, let me just put it that way. But essentially, let's go to it real quick. Let's go to like calendar. No, let's go to. All right, so as you can see, I've been kind of lacking, and this is this is literally just like this is just finals week. So it's my bad, guys. But school takes precedent over uh, stupid little coding problems that are ridiculously fun. But it's whatever. Today problem is about restroom guards, uh, and so like I don't know. I feel like it could be anything except for like restrooms. To have like guards in like robot guards like that. I don't want a Roomba going like teleporting into my stall. So I think it would be better to put like something else next time instead of like a clear like privacy violation. Maybe like a restaurant guard that teleports everywhere, and bro's just trying to like the historian's just trying to get his Big Mac. Um, but that's the only like problem I have with this question. Anyways, uh, the uh, question here is pretty simple. Essentially, you're given a bunch of little robots, their positions and their velocities. So I think it's better to just like take this example. For example, you have a robot that starts at position 2, 4 on the grid. So this is 0, 1, 2, 3, 4, and then 0, 1, 2, and that's 2, 4. And then it constantly moves in this direction forever and ever and ever, right? And so essentially, it would go up 2, and then it would go this way 3, right? And then it would end up here, or other way around. It would go up 3 and then over 2, right? And it would just keep on going in this section. And if it hits a wall, what it does is it teleports to the other side, like Pac-Man. That was pretty sick. And so essentially, this looks pretty difficult at first, but then like you figure out the trick, and it's like actually really easy, a little bit too easy. And the trick is basically just that like you have to use modulus, and it makes everything way easier. I thought it was gonna be like the one guard question where you have to make the guy like hit the wall, and then like that, and then I have to do that. Like I'd make it like increment every single time, but like once I realized this, like it was easy, right? So I'm gonna open this and split view really quickly. Essentially, what I realized was that if you had like the starting position, and then you um, would essentially just add the vector. So let's start with like only the x value of this robot. So right here it's at 2, and we have like this vector of 2. If we put in 1, you'll see that like location is 4 now, and that's true here. The location is 4 of the little guy. And then if you put in 2, it's 6, um, which is also the case here. And if you put in like 3, it's 8, which is the case here. And if you put in 4, it becomes 10, right? And now if you were to add another number, right? For example, if you add 5, it would be out of range. But if you realize, like, if you subtract 11 from this, it will not only be in range, but it will also be the correct index. So what's like basically the equivalent of like subtracting 11 as many times as like loops? You just like modulus it, right? And then now it's 1. And so uh, when I realized that, I was like, okay, this is Freelo. And it was. And so I basically just did this calculation for every single um, for all of the guys, including the little you know the things. And so the way I set it up was I essentially made a matrix with the width and height of the original, like the what's needed, and then I would basically just do the calculation that I did before, times it by 100, instead use like a higher width, like whatever corresponds, and then I would take that and I would increment that cell in the matrix, because you can have like multiple robots in one cell, and I just save that. And then what I do is I go through, and then you have to do the other annoying part of the solution, which is like this quadrant stuff, and you have to basically split the graph into four quadrants, and in these four quadrants, you would take what the total value is, and then you would multiply all of them together, right? And so this would give you like a safety factor that you needed to get, and so that was what I just basically did with this. If the matrix position was within these bounds, I would increment the solution that corresponded with it, like the solution cell, and then I would just multiply all of the values, right? And so that's what just this is, right? And that's pretty nice and easy. I got that pretty free. It took me like 30 minutes. It's fucking insane. Um, like when I say I locked in, I locked in. But then the moment the like second part came around, the second part was rough. Let's just say that. Essentially, there is uh, a a little Easter egg in the robot, where essentially a picture of a Christmas tree would form if a picture of a Christmas tree would form if you would just let the thing go on for as long as you could. And so I realized like there could only be like and so at first I thought that like okay, my bad guys. Essentially, I think I went through like three phases of trying to solve this. So first was just trying to brute force it, right? And so what I did was I essentially put the previous solution, uh, and then I basically would just loop through it, and then print out the matrix all pretty with yellow as the color of anything that's occupied, and I would just kind of like I would literally just like squint on my screen and be like, does that look like a Christmas tree? Does that look like a Christmas tree? Does that look like a Christmas tree? Um, and so I was obviously like getting lost, because there's no way I was going to be able to go through like the total of 10,143 possible combinations, which is like just the number of the height and width multiplied by each other. And obviously, like that didn't end up working, right? I was squinting at my screen for a long time. So then I thought that, so let me show you guys. Also, look at how sick my PowerShell is, bro. Like, this is Windows, guys. Essentially, what I did is, like, so, like, I just, like, would look. And so I thought that, oh, okay, so the Christmas tree would probably start at the very top, and it would just, like, go down like this, like that, right? So I was like, okay, so that means the middle cell should definitely be occupied. So I basically just sorted through everything that had the middle cell occupied, and I would only print those matrices. And I was just like way further, like insanely, like it was so bad. Like I couldn't find like nothing looked like a Christmas tree. Um, and so then I was like, okay, I give up. Um, and I went on Reddit.com, and I saw like what the Christmas tree looked like. Um, and then also like a premonition came um, in the form of like a Reddit comment that was basically like, maybe think about how to use that solution value from before, and like that premonition that I had, not like looking at a hint on Reddit or anything. Um, what I realized, like what like personally like realized was that like um, if you got like the previous solution value and you would like keep like, and since everything was like since the Christmas tree was in the center, that would mean that uh, since the Christmas tree is in the center, it doesn't really matter, or the solution value would be lower, because uh, there is more stuff in the center that isn't being counted. And so basically, I was like, okay, so then what I'll do is I'll get the solution value, and I'll basically print out matrices that are only less than a certain solution value. And so I ran this like three times. So I started it out by like decreasing it by like 100, and then like that much, and then by like a by like this was like 3 before I made this 0, and then I just printed out all the matrices that had that were less than this, and so that's what I just ran. And like you saw, like it found the little Christmas tree pretty quick, like somewhere down here, right? And there you go. There's the Christmas tree. It's pretty cool. But that was essentially how that worked, and it was pretty poggers if I do say so myself. Um, and that's essentially how I solved this problem. It's pretty sick. And yeah, uh, I think like this was a good question. I just wish that they'd put like a picture of what the Christmas tree looked like in the middle. So I guess we'll see. But I think that would have made it too easy for certain types of coders. For example, like the large language model individuals, the the people who are coding. Um, and so I think that was a good thing. I think we need more questions like this. Uh, and like I also want to like know if I learned how to think in that way of trying to find like patterns from the previous part of the problem and stuff like that, because like I never would have figured out on my own that the Christmas tree wouldn't be like filled in or whatever the you know so yeah. Also, I think this is just like a lack of experience, and that like there was a problem previously just like this, so or a problem that also had another Easter egg or something like that. I don't know. So it should have been. I probably should have one, done other problems instead of studying for my finals, and two, just like locked in. But like I hope that they have more problems like this, because I want to figure out if I could see the same pattern again or not, or like similar types of patterns or like ways of thinking, if that makes sense. Am I even recording right now? Okay, I am good.